All right, so today what we're looking at is I can add and subtract rational expressions. Now, the reason we're doing the adding and subtracting after the multiplying and the dividing is because it requires a little bit more thought on our part to do the adding and subtracting. And the reason being that it's based on just as you add and subtract rational numbers, in other words, fractions, rational expressions are similar. And the thing is, you need a common denominator. Okay, so it means that you have to do some work before you can actually add and subtract beyond the factoring. Okay, so again, let's look at some of the steps here that are involved. You can see that it's fairly lengthy this time, 8. And then we'll actually go and do some questions. So it's probably going to be a two-part video just because of the work that's required. Okay, step number 1, factor if possible. Remember this whole section, if unsure what to do, factor. State any restrictions. Simplify if possible. And when I'm talking about simplifying is up and down only because I cannot simplify this down here with this one over here because the reason being is because there's addition here. The same thing is true if it was subtracting. You're just not allowed to do that. All right, determine a common denominator. So that could take us a little bit of work, and express each rational as an equivalent rational with the common denominator. And what that really means here is if I need to have the common denominator of 4x squared, and I'm starting with an x, how do I make these two equivalent to each other? Well, obviously, I multiplied this one by 4x, so that means I have to multiply my 2 by 4x, and so that I end up with this as being an 8x. So you have to do that first and create these little equivalent rational expressions. Okay, the next thing we look at is after we have our common denominators and everything's equivalent, now we can add our numerators or subtract our numerators, and then we simplify them. Okay, it could be that we have to expand, gather like terms, even possibly factoring. So we do all of that. And then at the end, after we have our answer, we make sure that we state our restrictions with our answer, just like we've been doing all the way through these last few lessons. So let's look at one of the, I'm going to call them baby questions, in the sense that it looks easy, and sometimes those are the hardest ones. So when I look at this, first of all, I have 2a and I want to add it to 3 over 3a. So just like when I'm adding fractions, I'm going to put the 2a over 1 and leave that the other one the way it is right now. So I can't factor. So if I go back here, but I can state restrictions. My restrictions is a cannot equal 0. The next step says cancel if possible, but only straight up and down. Well, obviously 2a over 1, I can't cancel anything there. However, the second one, 3 goes into itself once. So really what I have for my question here is 2a over 1 plus 1 over a. Now, common denominator between, so I'm always thinking common denominator between a 1 and a obviously would be a, so I need to create my denominator of an a. So obviously the second one I didn't change. What did I do to the 1 to get the a? Well, I multiplied by a, so I must multiply the top by a. So I end up with 2a squared. And then what happens is I add or subtract them. Well, I've already done that in a sense. I can't factor it, so that is finished, other than I have to restate my restrictions. Okay, so that one was actually an easy one, but for some of us, we'd find that a little bit more difficult. Now, if we go to some other questions now, and I'm just going to bring up the screen just so that we're not being concerned with the questions down further. Okay, the next one. Okay, you can see I have 3 rational expressions I want to add and subtract together. And the first thing I have to do is factor. That's done. The second thing I need to do is state restrictions. The restrictions here are x cannot equal 0. And that would apply to every single one of those. The next thing I need to do is I need to come up with a common denominator. My common denominator has to be between x, x squared, and x cubed. So what does that mean? So for my common denominator would be x cubed, right? Because I can turn an x into an x cubed. I can turn an x squared into an x cubed. And an x cubed is obviously just an x cubed. So actually what I'm going to do is I'm going to change that to blue up here because that's not necessarily part of my solution. It's just my thinking that's going on there, that I know that it has to be x cubed. So now we continue with our solution and we have to create equivalent rationals. Now I like doing 1x cubed on the bottom and put my numerators on the top. So if I look at the first one, it's 2. And what did I do to the x on the bottom to get an x cubed? Well, obviously I did a squared. So I have the 2 has to be multiplied by x squared. Then I have a negative, and I'm going to put x plus 1. What did I have to do to x squared to get x cubed? Well, I multiplied by an x. And lastly, the last one stays as a plus 4. Okay, so we haven't created any more restrictions with this. Now it's just a matter of looking at that numerator. Now in this case, the numerator, I can do some simplifying by doing some expanding. So that's the first step. So we have 2x squared. We have a negative x squared and a negative x plus a 4 all over our x cubed. And continuing with that, so 2x squared minus x squared, so we have a 1x squared, a minus x, and a plus 4 all over x cubed. And my x cannot equal 0. Now I know that I cannot factor that numerator. It looks like I could, but I can't find two numbers that multiply to 4 but add to give me 1. That's just impossible. Okay, so let's look at question number 3 now. Again, I check to see if I can factor. I can't. I check to see if I have any restrictions, and we do. X cannot equal 0. Now this time, very similar to our last question, what is my common denominator here? Well, my common denominator between these would be, again, an x cubed, because I can turn an x into an x cubed, okay, by multiplying. Okay, I can't turn an x cubed into an x, okay, not by multiplying. So it's by multiplying that we turn them into each other. Okay, so if you have to divide or something, that's not going to work. So we have x cubed as our denominator. Here I have a 4x. The 4x, I didn't do anything to the denominator. So let's look at the next one, a negative 3. And what did I do to x? I multiplied it by an x squared. So I'm left with negative 3x squared plus 4x all over x cubed. Now, can I factor? Yes, I have a common factor on the top. I have a common factor of an x. When I take it out, I'm left with a negative 3x plus 4 all over x cubed. And again, we're not done because we can actually cancel here. X goes into itself once, x goes in x cubed squared. So we're left with negative 3x plus 4 over x squared, and x cannot equal 0. Now, another thing that you should have noticed about this question, and maybe some of you did as you watched this, is there was one step in our that was given to us, and it said, and I'm just going to go back the one page, and that was number 3. Simplify if possible, up and down only. Now, I did do one question on the previous page like that. This one here that we just finished also we could have canceled. Now the thing is, if you didn't see that you could cancel, what happens is you get what we had down here where we're able to factor out something. But this is the spot right here that we could have canceled an x out of the numerator and the denominator. And then what we would have a different common denominator, which would be x squared. But if you don't see that, it's not the end of the world, because you would do exactly what we just finished doing here. Okay, now we have a few more examples here, and let's just try. We'll get at least one done, I'm hoping. So just going to move that one down a little bit. Okay, so the next example. Okay, this time I'm subtracting, but you can see I have to do a fair amount of factoring in this case. Okay, so the first thing I need to do is two numbers that multiply to give me 4, add to give me 5, and both brackets are positive. So when I do that, I would have x plus 4, x plus 1. And the second rational, I need two numbers that multiply to give me 20, add to give me 9, both brackets are positive. So in this case, I'm going to use 5 and 4. Okay, so then again, we would state our restrictions, so we can see that x cannot equal -4, -1, and -5. Now my issue is I have to come up with a common denominator for this. Now it's a little bit different than the other questions where all I had was a term, like a monomial. This time I have binomials. So when I'm looking at this, I have to do a little bit more thinking, or maybe not. Maybe I just see it right away, what it should be. That was supposed to be a C, it didn't look like it. So you can see, what do they have in common already? Okay, they have an x to the 4th. So I'm going to use an x to the 4th as part of my denominator. And I don't need to put two of them, only one of them, because they have that in common already. And in order to get the first rational to have an x plus 5, I'm going to have to multiply this by x plus 5. And in order to get the second rational expression to have the same as what the denominator has in the first one, I also have to have an x plus 1. Okay, so in a sense, it's taking every single factor that we have. Okay, if you can see, I'm taking an x plus 1, an x plus 1, sorry, an x plus 4, an x plus 1. I already have an x plus 4, so I don't have to do that one again, and then an x plus 5. Okay, so that's the way it is each time. Now it's just a matter of making our equivalent expressions. So now you can see why I just wanted one denominator, so I don't have to write out a million things. Okay, now the first rational, what did I have to multiply it by to get my new denominator? Well, obviously I have to multiply it by x plus 5. So right now I already have a 1 here, so I have to multiply it by x plus 5. The second one has a 2, and what do I have to multiply it to get my new denominator? No, sorry, denominator. I have to multiply by x plus 1. So now it's just a matter again of expanding that, and I'm just going to bring my number 2 down here just because I'm taking a fair amount of work. And when I do that, I end up with an x plus 5 minus 2x minus 2 all over my common denominator. And a matter of collecting like terms, so I have a negative x and a positive 3 all over x plus 4, x plus 1, x plus 5. And finally, I need to put my restrictions, and my restrictions are x cannot equal -1, -4, and -5. Okay, so I'm going to stop the video, and then I'll put 2 more examples on for the last part of this lesson.